Hi everyone, this is Jeevan Reddy, pursuing MTech Power Electronics in Gokraju Rangaraj Institute of Engineering and Technology. Welcome to the session on my project, that is Design and Analysis of 7.5 watt quasi-resonant zero current switching buck converter. In this session I will explain about the operation of this converter, its advantages and its applications in real time.
The circuit is designed using isolated buck converter topology, and the controller which I have used is 555 timer. The software which is used to simulate the circuit is multisim. Before getting into the details of this project, we need to know about zero current switching. This is the power switch used in the circuit. It can be turned off at zero crossing of resonant current. In this project, the output voltage is regulated by a frequency control. As you can see, these are the specifications which I have used for designing resonant inductor and capacitor. Input voltage range should be 10 to 15 volts, output voltage 5 volts, output current 1.5 amps, and output power 7.5 watt. In particular, my frequency range is 33 kHz to 330 kHz. This slide shows the basic ZCH buck converter circuit, in which the main components are resonant inductor LR, resonant capacitor CR, which is connected across diode DF. Coming to the operation of the circuit is operated in 5 modes. Here in the circuit, load current I0 is flowing through LC filter and load resistor R. In mode 1, switch S1 is closed. At that particular instant, the diode DM conducts and the inductor gets energized and the current IL rises linearly. At the end of this mode, IL becomes equal to I0. In mode 2, switches remains on and the capacitor which is connected across the diode DM starts charging. Diode DM gets reverse biased and the inductor current rises to a maximum value, that is I0 plus Im, and de-energizes through capacitor and load. And the end of this mode, capacitor charges to a maximum value of 2 Vs. Here Vs is applied voltage to the converter. Mode 3, the switch is still on. The inductor current IL falls from I0 to 0 and the capacitor C starts discharging in this mode. Mode 4, the inductor current reaches to 0 and the switch gets off and the capacitor acts as a source to the load. At the end of this mode, capacitor voltage reaches to 0. Now in mode 5, switch remains off and again diode DM conducts and load current I0 flows through diode DM. This is the total circuit diagram of project. In this, the MOSFET which I have used is IRFZ44 N-type MOSFET for high switching frequencies. The resistor R1 and R2 are designed for setting on and off times of the gate pulses. This is the simulate circuit diagram which is simulated in multisim software. These are the on and off times of the gate pulses for which the values of R1, R2 and C are 3.3 kΩ, 15 kΩ and 1 nanofarad respectively. For which on time 12.69 microsecond, off time 10.30 microsecond, duty cycle 0.55 and switching frequency 43.4 kHz. Now we will have a look at the simulation results. In this, the output voltage which is obtained as 5 volt constant output per 15 volt input. This slide shows the gating pulses which are obtained from the 555 timer and provided to the gate of the MOSFET. This slide shows the results that are obtained from circuit in tabular as well as graphical form for switching frequency versus output voltage. It is theoretically verified and as well as practically verified from simulation circuit. These are the obtained design values for resonant inductor LR, resonant capacitor CR and resonant frequency FR. And next few slides show the mathematical calculations which are used in mode 1, mode 2, mode 3, mode 4 and mode 5. Coming to the advantages of the circuit, it is small in size, make compatible with other circuit. The switching speed is very high in the circuit. It is very less sensitive to temperature. It is highly efficient in terms of performance. Since the output can be controlled in the circuit, it can be applied for various circuits. It can be used in various applications such as switching mode power supplies, embedded systems and satellites. Coming to the simulation of the circuit, by running the simulation circuit and by giving the input of 15 volts, here we can observe the output current which is approximately 1.5 amps. and this is the output voltage, which is approximately 5 volt DC, and these are the gate pulses given to the MOSFET.
Thanks for your patience. With this, I want to conclude that this project can be used in various applications which is mentioned earlier, because I have analyzed and simulated this project and obtained desired results.